we now discuss the solution of a problem from the section Trigonometry, and the problem is related to the concept of the limit of trigonometric series. This question has appeared in the joint entrance examination main held on 28th June 2022 in the second shift. The given question is the value of limit n tends to infinity 6 times tan of in brackets sigma r is equal to 1 to n tan inverse of 1 by r square plus 3r plus 3 bracket close is equal to, we are given 4 options. Option A 1, option B 2, option C 3, option D 6. So we are given a trigonometric series. This is a trigonometric series. Sigma r is equal to 1 to n and limit n tends to infinity. And limit n tends to infinity of 6 times tan of in brackets sigma r is equal to 1 to n tan inverse of 1 by r square plus 3r plus 3. And we have to find the value of this trigonometric series. We now discuss the solution of the problem in detail. We are given limit n tends to infinity 6 times tan of in brackets sigma r is equal to 1 to n tan inverse of 1 by r square plus 3r plus 3 bracket close. That we will write it as limit n tends to infinity 6 times tan of in brackets sigma r is equal to 1 to n tr. What is tr? tr is tan inverse of 1 by r square plus 3r plus 3. So that is the one. In the denominator, what we see is r square plus 3r plus 3. That can be factorized and adjusted by a term, that is r plus 2 into r plus 1 will be r square plus 3r plus 2. Adjustment is to be made plus 1. So we will write 1 by 1 plus r plus 2 into r plus 1. So we will write that as tan inverse of 1 by 1 plus r plus 2 into r plus 1. Now the numerator 1 can be seen as r plus 2 minus r minus 1, because tan inverse of x minus y by 1 plus xy formula will help us. And that is equal to tan inverse of r plus 2 minus r plus 1, which is 1, by 1 plus r plus 2 into r plus 1. Let's recall this formula. This formula is tan inverse of x minus y by 1 plus xy when xy greater than minus 1 is equal to tan inverse x minus tan inverse y. So here x is r plus 2, y is r plus 1, and xy is r plus 2 into r plus 1, and r is running from 1 to n. So the least value of r is 1. R plus 2 will be 3, r plus 1 will be 2. R plus 2 into r plus 1 will be 3 into 2, that is 6. So 6, which is greater than minus 1. Therefore, this rule applies. So that will be equal to tan inverse of r plus 2 minus tan inverse of r plus 1. Now we take that sigma r is equal to 1 to n tr is equal to when r is equal to 1 in this tan inverse r is 1 plus 2 3 minus 1 minus tan inverse 1 plus 1 2 tan inverse 2. When r is 2, tan inverse 4 minus tan inverse 3. When r is 3, it will be tan inverse 5 minus tan inverse 4, and so on and so forth. When r is n, it is a tan inverse n plus 2 minus tan inverse n plus 1. So now you can see this one. I have been talking in the earlier discussions also that this is a telescoping series. In the telescoping series, cancellations take place. Tan inverse 3 minus tan inverse 3. They cancel. Tan inverse 4 cancels with the next bracket, tan inverse 4. Like that it goes on, and tan inverse n plus 1 cancels with tan inverse n plus 1, leaving tan inverse n plus 2 and minus tan inverse 2. So that will be equal to tan inverse n plus 2 minus tan inverse 2. Again, recall the same formula above. So here it is x and this is y, and xy is 2 into n plus 2. So 2 into n plus 2, and n starts with 1 to n starts with 1. So 2 times n plus 2 will be 2 times 3, that will be 6, which is greater than minus 1. Therefore, certainly this works. So tan inverse of n plus 2 minus tan inverse of 2 will be tan inverse of n plus 2x minus y minus 2 by 1 plus xy, 2 into n plus 2. So 2 in the numerator, 2 and minus 2 cancels, and in the denominator it will be 2n plus 5. So that will be equal to tan inverse n by 2n plus 5. So this is sigma r is equal to 1 to n tr. So what's that we want? We want limit n tends to infinity of 6 times tan of in brackets sigma r is equal to 1 to n tan inverse of 1 by r square plus 3r plus 3. This we have written as limit n tends to infinity 6 times tan of in brackets sigma r is equal to 1 to n tr. Sigma r is equal to 1 to n tr, we have seen tan inverse of n by 2n plus 5. That you write. So limit n tends to infinity 6 times tan inverse n by 2n plus 5. And we recall tan inverse x is equal to x for all values of x. Agreed. So that will be equal to limit n tends to infinity 6 times tan inverse goes off, and that will be n by 2n plus 5, and divide numerator and denominator by n. So that will be equal to limit n tends to 6 by 2 plus 5 by n. As n tends to infinity, 5 by n tends to 0. It will be equal to 6 by 2, that is equal to 3. So that is the sum of the infinite trigonometric series. That's what it says. So sigma r is equal to 1 to n tr is Sn, the sum of the first n terms, which is the partial sum. The partial sums we have taken and we have put here, and as n tends to infinity we have found out. That means you are practically talking about the convergence of the trigonometric series. It converges to 3. Let's look at our options. Our answer 3 appears against option C. Therefore, the answer to this question is option C. So that is the detailed discussion of the solution of a problem, the limit of a given trigonometric series from the section trigonometry. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.